Hi, we are from Design Team 3, consists of me, Nureszren, Kwok Kam Man, Thariq Ihza, Batrisyia Aliah, Wan Yee, and Salma Azkaa. So, for our presentation outline, it consists of major accident event, layer of protection analysis, heads up, operability, and reflection.
I will briefly walk you through the major accident events or MAE that can occur in a chemical production plant, specifically the production of cetyl alcohol. These events typically involve catastrophic consequences both for plant operation and the surrounding environment. So MAE in cetyl alcohol production can include chemical release or explosion, reaction runaway, equipment failure, storage accidents, and environmental incidents. This is the summary table of MAE, and the causes of major accident events typically arise from human factors, technical factors, and operational errors. So lastly, the impact of MAE have significant consequences, including on the plant, which is equipment damage, costly repairs, and downtime. On personnel, include injuries, fatalities. On the environment, which include pollution from spills or leaks, and on reputation or economy, there will be financial loss due to clean-up, fines, legal actions, and damaged reputations.
Next, we move on to the layer of protection analysis, or we call as LOPA. LOPA is a method used to estimate the risk of hazardous events in industries. It works by identifying event frequency and adding protection layers to reduce risk. The table shows LOPA categories such as safer design, alarms, shutdown system, and physical barriers like relief valves. Each category represents a safety layer. By combining these layers, industry can ensure safer operation and prevent accidents. Next, for our distillation column 1, hazards are categorized into chemical, thermal, mechanical, and also environmental. Chemical hazards involve flammable vapor release or explosion from chemicals like methanol or methyl palmitate. Protective strategies include inert gas blanketing, explosion-proof equipment, and proper sealing to prevent fire or toxic exposure. Other than that, thermal hazards like overheating are mitigated by safe operating temperature, cooling system, and SIS for reboiler trips. For mechanical hazards such as overpressure or blockage are addressed through pressure relief valves, routine inspection, and design safety margins to maintain separation performance. And lastly, for environmental hazards, including VOC or solvent emission, are controlled by vapor recovery units, closed-loop system, and community alert system to minimize impact and ensure regulatory compliance. Each strategy reduces risk by adding independent protection layers to safeguard operation, people, and also the environment.
HAZAP. HAZAP is stand for Hazard and Operability Study, which is a systematic method to identify process hazard and operability issue. How it works? The process is divided into several nodes by applying guide words such as more, less, no, or reverse. First, you need to do a derivation and then analyze the possible causes, consequences, and action required. Why use HAZAP? Because it is a highly systematic and detailed and also ideal for continuous chemical processes. So, for the first node, we have feed stream of distillation column from the enter 1 to DC1, which is the first guide word is no and the derivation is no flow in the feed stream. The possible causes of this is pipe blockage and the consequences is column can be dried out. And the action required is to install level alarm and check maintenance procedure and schedule. We also have deviation in more flow, more pressure, more temperature, also less flow, less temperature and less pressure, and then is following by the possible causes, consequences, and action required.
If we see no flow due to the pipeline leakage, it can affect to the product quality. We need to install the flow alarm, also the controller. A more flow situation from control valve failure can lead to the flooding. So we must install the level indicator and also alarm. When we see more pressure or more temperature occur, the consequences are serve an explosion. To mitigate this, a pressure relief valve is essential, and also for the temperature, we need monitor for overheating. A less flow or the low temperature situation can also lead to poor product quality, so we need to monitor with the flow and also the temperature alarm. First, let's take a look at the no flow scenario. This could be due to the leakage in the bottom pipeline leading to the potential loss of the product. The required action is to install the flow indicator and also the flow alarm. If we have more flow, a leak in the bottom string could cause the level indicator alarm to fail. Now for the pressure and the temperature. A rise in the pressure or temperature can lead to the explosion. To prevent this, we must install the pressure sensor and also the pressure relief valve. And for the temperature, a temper interlock and also the flame arrestor. If we have less or low flow pressure, it could lead to the product quality issue and the composition changes.
It's important to consider the operability factor for an equipment, especially distillation column. It is very important equipment in a chemical plant. There are 8 operability factors that have to be considered in order to ensure the safe and stable operation, time saving, the product quality, and flexibility. That all of it lead to a better. Now let us look at the operability factor one by one. First, with the operating window. It is important to ensure the distillation column works between the operating window to ensure there is separation happening. Therefore, we must use a robust control system. Next, flexibility and controllability. Wherever there might be change for the recipe of the demand by customer, must ensure that the distillation column can cater the changes, such as having adjustable reflux and reboiler setting. Reliability is also important. Wherever there is damaged equipment, ensure they have redundancy for critical equipment such as pump, reboiler, and stuff. Next, safety, equipment, and protection. Ensure having a safety instrumental system within the distillation column, such as having pressure relief valve, interlock, and alarms.
Moving on to the next key operability factors, we have the efficiency. Issues like prolonged startup time and feed contamination can lead to delays, higher costs, and fouling. To solve this, we can preheat the feed, use automated startup control, and also reject off-spec feed using filters. Next, during transition periods, problems like early feed introduction or improper shutdowns can cause flooding and off-spec products. Solutions include using interlocks tied to temperature and pressure, installing drain lines with level sensors, and also proper purging before maintenance might solve this problem. Also, dynamic performance challenges such as poor disturbance rejection can result in overpressure and safety risks. This can be addressed with proper PID tuning, cascade control, and better sensor placement. Finally, for monitoring and adequate data delays troubleshooting, this can be improved by installing the right instrumentation and analytic tools.
I'm very happy to have class with Dr. Kamarizan, especially when along the way we get to apply all our knowledge in our plant design project and discuss with our group member as well. This actually deepen our understanding. I hope I can bring all of this knowledge in the future when I work. Thanks.
Very grateful for this process safety class because it deepened my understanding about process design and operation, and it also taught me about critical thinking and always prioritize risk prevention.
This project under Dr. Kamarizan enhanced my understanding of integrating safety into plant design. I learned how tools like HAZOP help identify risk early and improve operability. It was a valuable experience that showed the importance of proactive safety planning in real-world chemical processes.
I learned a lot during doctor's lectures. I feel like the in-class activities that was done during almost all of the class helps me a lot to further understand the materials, and I hope I can apply my knowledge in the future. Thank you.
In my engineering studies, I think about how to apply our knowledge of HAZOP and also LOPA to identify and also mitigate the risk. I learned that instrumentation is a backbone of the process control and safety. I appreciate how this course is preparing me for my future career where safety is a paramount.
Thank you, Dr. Kamarizan, for teaching us along this semester. Actually, this course has deepened my understanding of the importance of process safety in preventing accidents and how to protecting people and the environment. I'm now more focused on applying safety principles in every stage of plant designs and operation.